Math 83, Unit 2, Lesson 2. We're going to graph a line, given a point on the line and the slope. So number 1, we want to graph the line that passes through the point -4, 2 and has a slope of -4/3. So to start out, we want to plot the point -4, 2. That means I'm going to go to the left 4 and up 2. And I'm going to plot that point. And from there, I'm going to find another point by using the slope. Now we learned in the lesson before that the slope, which is our m, is our rise over our run. And if we have a slope of -4/3, I can attach that negative either to the numerator or denominator. So I'm going to go ahead and attach it here to the numerator, -4/3. That means from this point, I'm going to go down 4 units because we have a -4. 1, 2, 3, 4. And then I'm going to go to the right 3. 1, 2, 3. And this is where my second point will be. From there, I can find a third point by going down 4. 1, 2, 3, 4 to the right 3. 1, 2, 3. And this is where my third point would be. Now you want to take your straight edge and connect the points. And there we've graphed the line. In number 2, we're going to start with the point -1, 1. So that means I'm going to go to the left 1 and go up 1, and this is where my point will be. And then we have a slope of 3. So again, our rise over our run is what our slope is. And if we have the whole number 3, the denominator is going to be 1. So from this point, I am going to go up 3 and then to the right 1 to find the next point. So 1, 2, 3 over 1, this is where the next point would be. And then I can't go further, I can't go up 3 over 1, I'm off my graph. So if I want to, I can rewrite this slope as a -3 over a -1, because a negative divided by a negative is a positive. And from this original point, I can come down 3 and then go to the left 1. So 1, 2, 3, and then left 1. And this is where my next point would be. 1, 2, 3 to the left 1. From there, I can connect the points. And now I have graphed a line. Another thing to notice about number 1 and 2 is if I were to look at the slope here of -4/3, that's a negative slope. So I know my line has to come down left to right, and it does. If I look at number 2, I have a positive slope of 3. That means my line is going to go up left to right, and that is exactly what it's doing. So that's another way you can double check if your line is graphed properly. In number 3, I want to draw the line that goes through the point -4, 0, and the slope is undefined. So I start by plotting the point -4, 0. That's on my x-axis. And we learned from the lesson before that any slope that's undefined is going to be a vertical line. Therefore, I just have to draw a vertical line through this point. And there I have graphed the line. In number 4, we want to graph the line that passes through 0, -2 and has a slope of 0. I start by plotting 0, -2, which is on my y-axis. I learned from the lesson before that anytime the slope is 0, we're going to have a horizontal line. Therefore, I can just graph a horizontal line through that point. And there I've graphed the line. So now we're going to discuss the slopes of lines that are parallel and lines that are perpendicular. First of all, parallel lines are lines that never cross. And if we were to look at an example, they would look something like this on a coordinate graph. Now, what's interesting about the slopes of parallel lines is that the slopes are always equal to one another. So if I take the slope of the first line, it's always going to equal the slope of the second line. Now, perpendicular lines are lines that cross at right angles. And they would look something like this. Where the two lines cross at 90 degrees. Now, what's interesting about their slopes is that they are negative reciprocals of one another. Now, what is a negative reciprocal? If one of my slopes was 3/2, the slope of the second line is going to be the negative of this, and then we flip the 3 and the 2 and it becomes negative 2/3. That's a negative reciprocal. And the other fact about it is that you can take these two slopes and multiply them together, and you're always going to get -1. So if I take this first slope and multiply it by the second slope, I'm going to get -1. So let's add here to our notes, I think I'm going to have to fit it right here, is that the slopes are negative reciprocals. So now let's go apply this. In part 2, we want to graph two lines on the same coordinate plane and then determine whether those lines are parallel or perpendicular. And we can do that by looking at them, but also we're going to compare their slopes. So first I'm going to plot the point 0, 0, and I'm going to call that A. And then -2, -5, that means the left 2 down 5, and that's going to be our B. And then I'm going to take my straight edge and connect those points. Now I'm going to find the slope of line AB, and to find the slope of this line, I'm going to start with the point B, and I'm going to count that I go up 1, 2, 3, 4, 5, and then to the right 2 to get to point A. So my slope is 5/2. Now I'm going to go ahead in part D here and plot the points 0, 5, that's on the y-axis here, and the point -2, 0, which is right here, on the x-axis, and now I'm going to connect with a line. So now that I've connected the points and drawn the line in of CD, I want to find the slope of CD. So I'm going to start with this lower point here of D, and I'm going to count 1, 2, 3, 4, 5 would be my rise, and then I had to run over 2 to get to C. Now we have to determine if these lines are parallel, perpendicular, or neither. Well, they look parallel on the graph, but the way we know for sure is that these two slopes right here are the same, and if the slopes are equal to one another, then the lines are going to be parallel. In number 2, we're going to do the same thing and plot the points E and F. So we go to the left 3 and up 2 to plot -3, 2, and we'll label that E. And then we're going to go to the right 5 and then down 2 to plot the point F. Now I'm going to take my straight edge and connect those points. Now I'm going to find the slope of EF, and I can see that the line is coming down left to right, so I'm going to come down 1, 2, 3, 4, and that's going to be a -4, and then I'm going to go across 1, 2, 3, 4, 5, 6, 7, 8 to get to F. So I had to do a run of 8, and -4 over 8 simplifies to be -1/2. Now in part D, I'm going to go ahead and plot the points for G and H. G is a +1 and then -4, so go to the right one, 1, 2, 3, 4. This is where G is going to be. and then H is 1, 2, 3, 4, 5 to the right and up 4. 1, 2, 3, 4, and this is H. Now I'm going to go ahead and take my straight edge and connect those points. Now looking at that line, I can tell that that line GH is definitely crossing EF, so I know it's not parallel. But we're going to look at the slope to determine whether those lines are perpendicular or neither. So if I start from G, I can see that it's going up left to right, so it's going to have a positive slope. And now I'm going to count from G. I'm going to do my rise. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, and then I go across 1, 2, 3, 4 to get to H, and 8 over 4 simplifies to be the whole number 2. Now if I were to look at these two slopes and compare them, the first slope is -1/2. If I were to flip around the 1 and the 2, it would be 2 over 1. If this first slope is negative, the second slope here is positive. These two are negative reciprocals of one another. And because they're negative reciprocals, I can see that these lines are perpendicular. So not only do they look perpendicular, but we proved it by comparing their slopes. In part 3, we're going to solve problems involving slope. On a certain day, the temperature dropped from 60 degrees Fahrenheit at 5 p.m. to 35 degrees Fahrenheit at 10 p.m. If the temperature dropped at a constant rate from 5 p.m. to 10 p.m. on that day, what was the temperature at 8 p.m.? Well, first we want to find out the difference between the two temperatures. So it went from 60 degrees Fahrenheit to 35 degrees Fahrenheit. So we're going to go ahead and subtract those and see how much it actually dropped. So if I were to subtract 35 minus 60 degrees, I'm going to get a -25 degrees Fahrenheit. Now I'm going to take the time and see how many hours have gone by. So if I were to go from 5 p.m. to 10 p.m. and the difference between the two, 10 p.m. minus 5 p.m., I can see that 5 hours have gone by. If I simplify this fraction, a -25 divided by 5 is going to be a -5 degrees Fahrenheit, and it changed or dropped 5 degrees every hour. We're going to go ahead and chart this out and see the temperature at every hour. So at 5 p.m. the temperature is 60 degrees Fahrenheit. Then at 6 p.m. it dropped 5 degrees, so we're down to 55 degrees Fahrenheit. At 7 p.m. it dropped another 5 degrees, so now we're down to 50. 8 p.m. we dropped another 5 degrees, we're down to 45 degrees Fahrenheit. 9 p.m. it dropped another 5 degrees, so we're down to 40 degrees Fahrenheit. And then at 10 p.m. it dropped another 5 degrees, so we're down to 35 degrees. And so our starting point here of 5 p.m. it was 60 degrees, we have that right here in the chart. And then we can see at 10 p.m. it's 35 degrees, which is right here in the chart. So we want to know what the temperature was at 8 p.m. We can see it right here in the chart that at 8 p.m. it was 45 degrees Fahrenheit. I'd like you to try number 2 on your own. Pause the video and give it a try, and then come back and check your answer. So if you subtract the temperature from 9 a.m. to 3 p.m., we're going to subtract 54 minus 42, and we see a change of 12 degrees. And then if you count how many hours have gone by from 9 a.m. to 3 p.m., and you count up from 9, you would count 10, 11, 12, 1, 2, 3. That's 6 hours. And then 12 divided by 6 is going to be 2 degrees Fahrenheit every hour. And so that's what it's going to change. So if we start at 9 a.m. in our chart at 42 degrees, and we go up 2 degrees every hour, at 10 a.m. we're at 44 degrees, 11 a.m. 46 degrees, at noon we're at 48, 1 p.m. 50, 2 p.m. 52, and 3 p.m. we're at 54 degrees. And so that matches up with our chart where we can see here 9 a.m. 42 degrees was right here, 3 p.m. 54 degrees is right here. So to find our answer, we want to know what the temperature was at noon. It was 48 degrees Fahrenheit at noon.